Hey guys, Nick from Aguazio, here to show you the quick start for MLRun. We'll go ahead and run through it and see what it looks like in Jupyter as well as the MLRun UI. There is a full documentation page that you can look at, and if you'd like to follow along at home, you can download this page as a Jupyter notebook, or you can open it directly in Google Colab. I also want to note this great page in the documentation called Tutorials and Examples, which has the quick start itself, but also a bunch of other great tutorials on specific parts of the workflow, for example, training, serving, monitoring, adding MLOps to existing code, and a lot more. Each one of these will have its own dedicated tutorial and video as well. So I've downloaded this tutorial as a Jupyter notebook and opened it up here in Jupyter, and we'll run through it together. I want to note that I'm not going to cover everything, so I strongly suggest you read through it yourself and take a look at all the details, but I will be covering the main points. So the first thing we'll do after installing and importing MLRun is creating our project using mlrun.getOrCreateProject, passing in the name and a few other parameters. This will give us our project object, which will be used to add functions to as well as execute those functions. So next we'll create our very first MLRun function using this piece of code. It's a very simple script with one Python function that essentially grabs a dataset from sklearn and returns it as a pandas data frame. We're also returning the name of the label column. This is 95% regular Python. The only thing we're adding is this MLRun handler decorator. This tells MLRun we'll be returning two things. One is called dataset and one is called label column, and it will know behind the scenes based on the type of the object how to log it in the experiment tracking system. Next, we will use the project object to actually create our MLRun function using project.set function, passing in the name of our Python file that we just looked at, as well as the name and some other parameters, like the fact we want to run it as a job with this Docker image and this Python function. Then you can save your project to add the function to it so we can run it later. So now we can run our very first MLRun function using the MLRun project. We're going to say project.run function, pass in the name of the function we want to run, as well as some parameters. In this case, I'm passing in an optional parameter called local. Local equals true means run it in your local environment like in Jupyter. Local equals false, which is the default, means run it at scale on Kubernetes. We'll see that a little bit later. Once you've run your function, you have this nice printout here, and you can also go ahead and open it in the MLRun UI, where we can see a bunch of stuff. For example, under artifacts, we can see the data set that we logged. Under results, we can see the label column that we logged, and there's a bunch of other great metadata information that you can see every time you run a function. Now we're going to train a model using the dataset that we just created. Instead of creating a brand new MLRun function, we're actually going to import one from the MLRun function marketplace. You can get there by clicking here, which will open up the MLRun function marketplace. Now there's a bunch of great functions already out of the box that do cool things. The one we're going to be using today is called AutoTrainer, which is in the realm of AutoML. So you're going to import it by saying mlrun.import function, and we're going to point to the marketplace by having this hub prefix, and then the name of the function, which in this case is AutoTrainer. Then again, we can run our function by using the project.run function, pass in the function as well as some parameters. In this case, one of the parameters is our dataset from our previous run. You'll also notice that there is no local equals true. In this case, the default is local equals false, which means it will run behind the scenes on Kubernetes. You can see here it says job is running in the background with the name of a Kubernetes pod. From here, you can again see the printout statements as well as open it up in the MLRun UI, where we have a lot of great stuff that was logged using the AutoTrainer function. For example, we can see the parameters we passed in, some evaluation metrics that we got, and we can look at some other artifacts, including things like the model itself, a confusion matrix, feature importance, and a lot more. So there's a lot of great stuff in the function marketplace and that you can get by using these functions. Next, we're going to serve the model that we just trained, and we're going to do that by creating a brand new MLRun function using mlrun.newFunction, where the type is serving because we're serving a model. From there, we're going to go ahead and add our model to the serving function using servingFunction.addModel, where we say that the path to the model is the output of our training job, pointing to the model that we just trained, and the class name, this specifies the model's behavior, is using one of the built-in classes in MLRun, in this case the sklearn model server. I want to note that there's a bunch of great built-in model servers for all the common frameworks. You can also build your own custom model server if there's not one here that you need. You can read about this more under Deploy Models and ML Applications in the docs. So now we can print out our model server and see what it looks like. In this case, it's very simple because we just have a singular model, but as we'll see in a moment, you can get a lot more advanced. This is an example of a much more complex model deployment, which includes steps for data enrichment, pre-processing, a model ensemble, as well as final post-processing. But really, you can do anything you want to do in real time, including data transformations, aggregations, and a lot more. You could read more about this under online serving pipelines. Next, we can test out our serving function using a mock server. This simulates a model deployment without actually having to deploy to make sure everything is behaving as expected. You can do this by saying serving function.toMockServer, which gives you the model server, which you can then send data inputs to, and it acts exactly like a model server. So it's finally time to deploy our model into production, and we'll do that with a single line of code. Project.deployFunction, and pass in our serving function. This will take our code, all of our parameters, all of our pre- and post-processing, package it all up into a container, deploy it on Kubernetes, and expose it to an endpoint. And remember, this is more than just a simple model endpoint because it contains all of your transformations, pre- and post-processing, business logic, everything all into one deployment, which gets deployed all at once and supports rolling upgrades, auto-scaling, and all that fun stuff. You can test this out by sending post request either via the function object itself or just a regular post request. So we send data to it and we get a response just like we'd expect. So that's a quick start for MLRun. Thank you so much for watching till the end. I want to reiterate that MLRun is more than just training and deploying models to an endpoint. It's about building a production-ready application that includes everything from data transformations to your business logic to the model deployments to a lot more. So if you're interested in learning more about one of the individual steps we saw in the quick start, I recommend taking a look at the targeted tutorials, where we have individual tutorials on specific steps like training, serving, monitoring, and a lot more. Each one has its own tutorial and its own video. So thank you so much. We'll see you in the next one.